In these notes, we'll continue our work with functions and start looking at graphing functions. And for today's notes, we're going to look at the sort of one of the more simple ways to graph a function, but it is one of the most effective, and it works with any type of function as long as it's a two-variable function, which makes it really useful later on when you don't know how to graph a function that you're presented with. But for these notes, we'll focus on linear functions, and what we'll be doing is graphing these with T-charts, or just a table of values. So just a quick reminder, linear functions form lines when graphed. So all of our graphs today will form a straight line. So if you get a graph that's not a straight line, you know you did something wrong. Something we'll have to do while we're using T-charts is be able to rewrite a function or solve it for y. Rewrite a function in xy notation, which is just getting y by itself. So your function starts with y equals, so we can plug values in for x later on. So let's just practice that. The first one here, we have negative x plus y equals 6. We'll want to move this x term to the other side, and we'll do that by adding to the opposite operation, add x to both sides. So y equals x plus 6. Something else we'll practice in these notes is writing these in the proper format where the x term comes before any of the constant terms. Okay, number 2, we have to get rid of the 3x. So we'll subtract it. You've got negative y equals negative 3x plus 1. Finally, we're going to divide by negative 1 to get y by itself. And so y equals 3x minus 1. Last one here. Again, you've got to get rid of this x term, so the y term is alone. We'll add 2x to both sides. So negative 4y equals 2x plus 3. Write the x term first. Divide by negative 4. We are going to get a fraction on this one. Y equals 2 over negative 4. That reduces to negative 1/2 x. And then this is also going to be a fraction, minus 3/4, just like that. That is fine. We'll leave it like that. Okay, so if your equation is not solved for y, if it's not in xy function notation, when you're using a T-chart, you'll have to get it into that notation first. Okay, let's practice actually using T-charts or just a table. They're called T-charts because at the very simplest, you make a T and fill in x, y in your numbers. For these notes, they'll be filled in for us, so there's a little bit more to it, but that's essentially what we're doing. So we have y equals 2x minus 1, and this middle column here is to show our work. It's not necessary, but it does help, especially when the equations get a little more complicated. So what we're going to do is plug these numbers in for x here. We'll evaluate and get our numbers for y, get our output for each input. So for negative 1, we're going to do 2 times negative 1 minus 1. That's negative 2 minus 1, which is negative 3. For 0, that's 2 times 0 minus 1, or 0 minus 1, which is negative 1. And for 1, that's 2 times 1 minus 1, which is 2 minus 1, which equals 1. And so what we've done here is we've found our output values for each input. And what we're going to do is use those as ordered pairs to graph the function. So we have negative 1, 3 is a point on our graph. So that's left 1, down 3 right here. Our next point is 0, negative 1. And after that is 1, 1. And so we can see we have a straight line that we can graph. So again, all of your graphs on these notes will make straight lines, and if they don't, there is a mistake somewhere. Okay, we have a fraction in this one, y equals 1/2 x plus 2. That's okay, but you'll notice the numbers that we're using are different. On the first one, since our coefficient here on the x is a 2, we just use negative 1, 0, and 1. And that's what we'll generally use whenever you make a T-chart. Center your numbers around 0. However, in this next one, since we have a fraction coefficient with a denominator of 2, we're going to base our numbers here off of that denominator. So instead of counting by 1s, we're going to count by 2s and use -2, 0, and 2. The reason we do that is so that our numbers will be divisible by that denominator, and that will allow us to get whole numbers for our outputs, which will be easier to graph in the end. It'll be the same line, they'll be a little more spread out, but they'll be much easier to work with. So we've got 1/2 times -2 plus 2. Well, half of -2 is -1, and that's why we're using these even numbers, because 2 divided by 2 is 1, and if we were using 1, we would get a fraction. So -1 plus 2 is going to equal 1. This next one will plug in 0. So 0 plus 2 is 2. And then for this third one, we're putting in 2 for x. Half of 2, or 2 divided by 2, is 1, plus 2 gives us 3. So now we can plot these points on the graph. -2, 1, 0, 2, and 2, 3, which do make a straight line. By the way, if I'm going too fast, if you're trying to write these down while I'm working through them, just pause the video and write down what it is. Better than trying to listen and write at the same time. Feel free to copy all this down and then maybe go back and listen to the explanation again. Okay, so now we're going to make our tables ourselves. So we're going to make our table of values. Remember to solve for y first. So on some of these easier ones where you're just multiplying and then adding, it's not super necessary to have that middle column. All I really need is an xy column, but it can help if you get stuck. So again, I like to do 5. These up here had 3. I like to do 5 numbers. So I'm going to do -2, -1, 0, 1, and 2. And these are the 5 numbers I would expect to see on an assignment from this class. So let's plug in -2. -2 times -3 is +6, plus 4 is 10. Putting in -1. Again, we're putting these numbers right here for x. -1 times -3 is +3, plus 4 is 7. 0 times -3 is 0, plus 4 is 4. 1 times -3 is -3, plus 4 is 1. And 2 times -3 is -6, plus 4 is -2. So now we have all of our xy pairs. We can just graph these points. So -2, 10 is just off the graph up here. -1, 7. 0, 4. 1, 1. And 2, -2. So while having just these middle 3 points is fine, having 5 really confirms the straight line. Because if you have just 3 and you get one of them wrong and your line kind of does this, it's impossible to know which one of these points is the one that's incorrect, because any 2 of them would make a straight line. You know, if you had your dots and they kind of made this. But if you have 5 points and only one of them, you know, is out here or something, you can be pretty sure which one's wrong. So I like to do 5 points just because it helps make a better picture, as long as you draw the line correctly. It's good enough. But so I would say use 5 and center them around 0. So -2 to 2, these 5 right here, this is typically a good set to use. When you have a fraction, you'll have to adjust it a little bit. All right, next one here. Y equals -2x plus 3. Again, let's make our T-chart. -2, -1, 0, 1, and 2. And we're going to plug these numbers in right there. So -2 times -2 is +4, plus 3 is 7. -1 times -2 is 2, plus 3 is 5. 0 times negative 2 is 0, plus 3 is 3. 1 times negative 2 is negative 2, plus 3 is 1. And 2 times negative 2 is negative 4, plus 3 is negative 1. Something else you should notice, as long as you have these numbers in order, like this, these numbers here will follow a pattern. So in this case, it's minus 2 every time, which if you look at our equation, that's the coefficient on the y value, or on the x value. So you should notice a pattern as you're filling out these T-charts. Okay, negative 2, 7, left 2, up 7, negative 1, up 5, up 3, 1, 1, and 2, negative 1. All in a straight line, looks good. Okay, let's move on to the next one. 2x plus y equals 8. So again, we have to solve for y first. We're going to subtract 2x here. So y equals negative 2x plus 8. All right, now let's make a T-chart. And we're going to use those same 5, negative 2, negative 1, 0, 1, and 2. We're going to plug them into this x right here. So negative 2 times negative 2 is positive 4, plus 8 is 12. Negative 1 times negative 2 is positive 2, plus 8 is 10. Put in 0, we get 0 plus 8, which is 8. And so now you can see the pattern forming. We're going down by 2 each time. 1 times negative 2 is negative 2, plus 8 is 6. And 2 times negative 2 is negative 4, plus 8 is 4, which does confirm the pattern, so we can be pretty sure we did this correctly. Now, negative 2, 12 and negative 1, 10 are both off the graph, so I'm going to skip those. We'll just go straight to 0, 8. And that's fine. If they're off the graph, you can skip them. 1, 6 right here, and then 2, 4 right there. So there is your line. These three are in a straight line, and because the other two fit the pattern, we can be pretty sure that they will as well. Let's take a look at number 4 here. Again, we have to solve for y, so let's subtract 4x. Negative 3y equals negative 4x plus 6. We'll divide everything by negative 3. So y equals, two negatives make a positive, so that's 4/3, leave the fraction, 4/3 x, and then 6 divided by negative 3 is negative 2. So here is the equation we'll be working with. And because we have a fraction, we're going to use slightly different values for x. I'm going to put this over here since out of room a little bit. We want our numbers to be divisible by 3. So we're going to use negative 6, negative 3, 0, 3, and 6. It's basically the original numbers multiplied by that denominator. So instead of negative 2, 0, 1, and 2, we're going to multiply those by the denominator, which is 3, and get negative 6, negative 3, 0, 3, and 6. But those are the numbers that are divisible by 3, that are the closest to 0 and the smallest. Okay, so we're going to plug these numbers in here for x. And what this 4/3 is going to do, it's going to multiply our numbers by 4, divide them by 3, and then subtract 2. Kind of a process, but that's all right. All right, so let's put in negative 6. You can also divide by 3 first if that makes it easier. So negative 6 divided by 3 is negative 2. Times 4 is negative 8. Minus 2 is negative 10. Negative 3 divided by 3 is negative 1. Times 4 is negative 4. Minus 2 is negative 6. 0, that goes to 0 minus 2 is negative 2. Put in 3. 3 divided by 3 is 1. 1 times 4 is 4. Minus 2 is 2. And 6 divided by 3 is 2. Times 4 is 8. Minus 2 is positive 6. And again, if you look, we have a pattern. We are increasing this by 4 every time, which again is that coefficient there. on the x. The reason why the 4/3 doesn't come into play is because we changed our inputs to be divisible by 3. Okay, let's graph it. So -6, -10 is off the graph. -3, -6 is here. 0, -2, 3, 2, and 6, 6 right here. So you see these are quite a bit more spread out, and that's because our x values are more spread out. But that's fine, we get the same graph. Okay, moving on from t-charts a little bit, just to see if a function is linear from the equation. So a function is linear if it has one or two variables, so just x and y, or just x or just y. The independent variable x, so our input area, has to have an exponent less than or equal to 1, is not in the denominator of a fraction, is not in a square root symbol. There needs to be no variable multiplication, and the dependent variable y has to have an exponent of 1. So all the stuff in here that is not linear. Can't have an x squared, can't have xy, x in the denominator, x in the square root symbol, y squared. None of that stuff is linear. So we're going to go through a bunch of equations and just say if they are linear or not, and if not, we'll circle y. So the first one, y equals 3x minus 4, that is linear. Just going to give it a check mark. Y equals x squared is not linear because of this x squared. Y equals -5, yep, that's linear. Same with x equals 7. One variable equations are just fine. This would be a horizontal line, and this would be a vertical line on the graph. Y over x equals 12, well, right here. That's a no-no, not linear. 3x minus 4y equals 8z, so this third variable makes it not linear. 3y equals x over 2 plus 5, this is fine. X can be in the numerator of a fraction, just not in the denominator. -2y equals 3 over x plus -7. This right here, that's a no-no. Can't have an x in the denominator. Square root of x, yeah, same thing, not linear. xy, no variable multiplication allowed. 5 minus 3x equals -8y plus 4x. Even though there are two x's here, when you combine them, that's fine. So they will go together eventually. So when we say only two variables, it means two distinct letters, but there can be more than one term for each one. And then here we got two things keeping it from being a linear. Y squared, x to the 4th. No. The biggest exponent allowed is 1. Okay, so there's a quick overview of whether or not a function is linear. And quick overview of t-charts. So basically you're plugging in values for x to get corresponding values for y to graph the function. There are just a few tricks like solving for y first and adjusting your input values when you have a fraction that you need to watch out for.